good morning, good evening, good afternoon, whatever time zone you are from. Welcome to this talk about machine learning for Oracle professionals. My name is Helskyaho. People know me as Heli from Finland. I have graduated from University of Helsinki with a master's degree on computer science, and I'm currently working on my doctoral studies. I've been working with Oracle products for many, many years, and always my favorite has been data and databases. And that's why machine learning is very exciting for me because it's all about data. I'm a CEO for Miracle Finland, which is a small consulting company in Finland. I'm an Oracle ACE Director, Oracle Groundbreaker Ambassador, and I have been listed as one of the top 100 influencers on IT sector in Finland in 5 years in a row. I'm a public speaker and an author, and I have written 2 books. The first one about database designing, and the second one I have co-authored with 4 other people about SQL and PL/SQL. So what is machine learning? Machine learning is an important part of artificial intelligence. Machine learning teaches computers to learn from experience using algorithms and, of course, the data. Arthur Samuel described machine learning in 1959 to be the field of study that gives computers the ability to learn without being explicitly programmed. In other words, we could say that machine learning is a systematic study of algorithms and systems that improve their knowledge or their performance with experience. So why are we talking about machine learning and why today? We have more and more data, the volume. We have different data models and different data formats, the variety. The loading of data is in progress while we are already trying to analyze the data, the velocity. Not all the data is reliable, the veracity. So in our relational database, we know what we have and we know if it's reliable or not. But when we are using external data sources that might be in any kind of data model coming from any kind of source, we cannot be sure how reliable the data is. So we have to be prepared to have data that is not reliable. One of the biggest problems is that we don't actually know what we are looking for. So we have a lot of data and we just want to find something interesting or important from that data, but we don't know what it is. And also those data experts, those people who know what the data really means are non-technical people, the business people. And they are not technical people able to write code or use SQL. So we have to be able to support them with visualization. And all this must be done efficiently and fast. And of course, as much as possible by machines, because otherwise we cannot do it efficiently and fast 24/7. Machine learning might be our answer. It's also a thing that we are able finally to use machine learning. So 1959, we didn't have the technology, the hardware solutions, the software solutions, and so on, that really made it possible to do the things that we are able to do today. So we live in a very different world. We have improved technology with GPUs, TPUs, and so on, and the storage price has gone down dramatically. So we are able to store all the data available. We have existing data sets that we can use to train our models, and we have pre-trained models that we can use in our training process. And we have a lot of research that is very helpful for us to build more complex things using machine learning. And so many other things. So we are living in an environment that really needs machine learning because we need to do a lot of things fast and efficiently with a lot of different kind of data. While the data is loading in, we are already processing it and so on and so on. But we are also finally able to really use it. So when to use machine learning? When you have data. It sounds stupid, but it's a fact. It's no point even trying to do any machine learning things if you don't have data, because it's all about data. It cannot be performed without data. So when the rules and equations are either very complex, like in image recognition, or they are constantly changing, like for example in fraud detection. So the nature of the data changes and the program must adapt to that. These are the situations when machine learning might be the solution. So you are not able to program if, else, and so on, because it's either too complex for that or the rules are changing frequently. Some real life use cases for machine learning. Spam filters, for example. You cannot program the spam filter because the spam is changing every day. Or log filters or maybe log alarms. Data analytics, image recognition, speech recognition, medical diagnosis, robotics, and so many other areas. But in real life, machine learning can be used everywhere. So there is no single business that could say, we do not need machine learning or we cannot use machine learning. If your business has data, you are able to use machine learning. The other question is it useful in that case or not? It all depends on the questions you have for the data and the kind of data you have. But there is no only one business area that would be a machine learning business area. But when we are doing machine learning, there's a thing that you have to remember all the time. Whatever we do with machine learning, it's always an approximation or a sophisticated guess. It's not 100% fact, even though you have the best model in the planet. So machine learning searches for patterns and trends from your data. Sometimes these patterns and trends it finds are useful. Sometimes they are not useful at all. We can be predicting future outcomes. Sometimes these predictions are correct, sometimes they are not. Or machine can be learning new skills. Sometimes, well, first of all, it takes a long time. And the question is, did it really learn what we wanted it to learn? So it's always close enough, but you have to be sure, you have to check that whatever the computer did was what we really wanted it to do. Machine learning can be divided in three categories. First of all, we have unsupervised learning. Secondly, we have supervised learning. And thirdly, reinforcement learning. Unsupervised learning is about learning from unlabeled input data by finding some kind of hidden patterns or intrinsic structures in that data. So in other words, we don't actually know what we are looking for. We just have data that we know nothing about, and we want to find something useful from that. We typically use unsupervised learning when we don't have a specific goal. What are we trying to do with machine learning? We're trying to find something useful that might be a task for our machine learning. The target variable is unknown, so we are not predicting the temperature tomorrow or the house price for my house or anything like that. We don't know what we are going to target. We are not sure what information the data contains. So we have a lot of data, but we are not sure what it is. So we're trying to find something useful from that data. Or we might want to reduce the features of the data as pre-processing for supervised learning. This process is called dimensionality reduction. The most common method for unsupervised learning is clustering. So we define how many clusters we want to have. In this example, we have two clusters. We have greens and we have the purple cluster. And we ask the computer to set all the data points we have into two clusters. And that's what it does. It defines what those clusters are and sets all the points to those clusters. Another example might be anomaly detection, which means that we are trying to find something that is very different from all the other data points from our data set, something that is very different. In supervised learning, we have a known target. So we are trying to predict, for instance, if this customer is worth a credit card or not. So should we give a credit card to the customer or not? Or which of our employees are about to leave the company so that we can go and talk to them before they leave? Maybe they will stay. Or what is the temperature next Monday? Because I want to go for running. Is the temperature going to be good? Is the sun going to be shining? And so on. So predicting something that we already know what we are trying to predict. So we are training a model on known input and known output data to predict future output. But always remember the uncertainty is always involved. So this is not a 100% fact what we are getting from the process. After we train the model, we test it with known input and known output data to know how well it actually performed. And when we are ready with that, we can go to production if we are happy whatever came out. So classification is one of the main methods for supervised learning. Classification is putting things into classes, pictures of cats or pictures of dogs. So often people confuse classification and clustering. They do sound a little bit similar, and the reason is that they are two methods of pattern identification. So they are the same in that way, but they are different in the fact that classification uses predefined classes. So I already tell the classification, I want to have these pictures in two categories, cats and dogs. While as when I'm using clustering, the clustering itself identifies similarities between these objects and decides which one it is, number one or number two. I don't say it's cats and dogs, I just say it's two groups, two clusters. And the algorithm puts these data points into one of the clusters based on similarities or differentiations between these data points. These groups are called clusters, and the number of clusters is a thing called hyperparameter. Hyperparameter is a parameter that I define before I even start machine learning process. So it's a kind of pre-parameter for the process called hyperparameter. How many clusters will we have? We will have two clusters. Take all the data points and put them in one of these two clusters. Another supervised learning method that is very useful is regression. So in classification, we put data points in classes, cats, dogs, worth credit card, definitely not worth credit card. But in regression, we are trying to find a number. The temperature next Monday, should I go running or not? The stock price for Nokia stock tomorrow, and so on. So we have the house price and whatever. So we're trying to predict a number based on facts that we already know about this particular um, item. Then people often talk about deep learning. And I quite often hear that deep learning is the solution because it's simple and easy. Well, first of all, it's not simple and it's not easy, but it is actually a very good solution for some cases. So what is this deep learning? I think this picture explains it quite well. So in the traditional machine learning that we just spoke 2 seconds ago, we do feature extraction, and after that we do classification. So we decide what are the features, how the features will be handled and so on before we start classification. Features means like attributes or columns like age, address, is my house close to water, is it in the middle of the forest? So this kind of features. So what are those features that will affect the classification process? In deep learning, the machine does feature extraction for me, so I don't have to do it at all. So it's kind of less work for me, more work for the computer. But of course, it's not a silver bullet for everything. It can be used for, let's say, computer vision, or maybe face recognition, speech recognition, text recognition, text processing, any of these that are quite complex in different layers. But it does need a lot of data and a lot of resources. So with the same data set that I can do my traditional machine learning, I probably cannot do deep learning because it needs more data. But the solution might be uh, already existing data sets that I can use for training, or maybe even pre-trained models, or maybe transfer learning. So one of the processes already learned something that I can transfer here. This I like to explain like when you are teaching your kids, don't burn your fingers, this is hot. But they don't believe you, they still want to try if it's hot or not, and they will burn their finger. So this transfer learning sometimes works, sometimes not, just like when you are training your own kids. So it's based on neurons. So we have neurons that will have inputs, this axis here on the left. So each input goes to neuron, it gets its weight, and a bias is added to that. And using activation function, we get the output, the prediction. You will see the activation function on the lower right corner here. So every input is multiplied by its weight. These are added to each other, and then the bias is added. And using activation function, we get the output. There's plenty of different activation functions, and that's one of the things that you might want to be tuning when you are doing the model design. So hyperparameter tuning and the model design is something that is very important when we do deep learning. How many epochs? So one epoch is when an entire data set is passed both forward and backward through the neural network once. What's the batch size that would be the best? So epoch is divided into smaller sets, batches. So what's the good batch size? How many hidden layers should we have, and how many units should we have? How many neurons in each of these layers? What is the correct weight? What's the correct bias? What activation function should we use? There's different options. Which one is the best for our case? What kind of learning rate step size should we use? What kind of gradient descent? What kind of optimizer to use? And so on. So even though it sounds simple to use deep learning, it still needs a lot of knowledge on how to really design the model and how to tune the hyperparameters. Actually, the way a neural network learns is called backpropagation or backward propagation. That means that, so here we got the input coming to our layer 1, then it goes to layer 2, and so on and so on. Every time we use the weight and we use the bias, remember when we talked about neurons, and in the end we come to prediction. Using loss function, we compare the prediction to the true target value to get the loss score. Using the loss score, the optimizer updates the weight of the last layer in our network, and so on and so on. So using this method, we get our weights optimized for our learning process. A convolutional neural network is even further from that. So this is something we use for image recognition. So on the right-hand side, we have the neural network we just talked about. But on the left-hand side, we have convolutional layers. So the input is sent convolutional layers, after that to neural network, which will produce us the output, the prediction. The convolutional layers consist of filters, output, and pooling layers. When it goes through all this, it's been flattened so that the neural network can process it. All that we do here is about matrices. These are matrices. Matrix in different way. We multiply them, we use kernels and so on and so on to process the matrix to the next step of our process. This is actually quite efficient for image recognition. So it's called convolutional neural network. So what are the use cases for deep learning? Well, text and voice, any kind of things to do with text and voice, because they are quite complex, like maybe natural language processing, automatic speech recognition, transforming text to speech, machine translation, or maybe even a resume or summary of a text. So a lot of different possibilities for using deep learning for text or voice. For some people that have raised a concern that there is no need to learn to read anymore because the computer is doing everything for you. Well, I don't really concern about that because I think that everybody should learn to read anyway. One example is generating. So this is the talk to transformer. You can see the link on the bottom right hand side bottom. Uh, so the idea is that I type here a little bit of text and the computer is generating more text for me. Another example of similar kind of thing is this text generation API. Also, the link is here on the right hand side. So this is even generating more text than the previous one. So I just type something and I say submit. Let's say I want to generate an abstract for my presentation using this. Well, at the moment, what it's giving me is not very useful. So I would definitely not use this as my abstract. But it's very interesting that it's able to generate somehow a text that looks like it's relevant to the content that I type in the small box. So I'm pretty sure this will improve a lot in the near future. Of course, translate is something very useful. So some years ago, when I was trying to translate Finnish language to any language, it didn't actually make any sense because the translations were nonsense. Finnish language is quite different from many other languages, so translating Finnish is not simple. Uh, Here, it's already doing pretty good job. So today, translations, even Finnish translations, are very, very good actually, except when there's some kind of special words. Like here, I was trying to, well, in Finnish, I said, Heli is going to give a presentation about deep learning. Well, it didn't know the word deep learning. Instead, it was translating it to in-depth learning. So special words are still missing, but actually the translations are pretty good. Another use case for deep learning might be a recommender system. So recommender system produces suggestions or recommendations to assist the user for decision-making process. So decide what movie to watch or something like that. There's three different kind of recommendation systems, recommender systems. The collaborative filtering recommender system that is recommending based on decisions of other users that are similar to you, what they have made. Content-based recommender system is recommending based on similarities of new items. So you have bought an item earlier that is very similar to this item. So the recommender system is recommending this to you. Hybrid recommender systems are using multiple approaches together. Amazon is a very typical example of recommender system. So here it's recommending me Kindle book deals. Unfortunately, none of this is something that I would buy. But the problem is not Amazon. The problem is lack of data. So Amazon doesn't know anything about me. It only knows that I have written books and it knows that I have ordered shampoo when I was in Tokyo. That's all it knows about me. Because whenever I'm ordering a new book, I ask my son to do it and he's using his profile. So all the books that I have actually ordered are now his books. So his profile is probably very interesting too. So based on these facts, she writes books and she's ordering shampoo in Tokyo. Amazon is making these guesses. Well, most of these books are in language I don't even speak. So lack of data about me is making it impossible to give me recommendations. Netflix is another classical example. So this one is in Finnish now. It can translate it into Finnish very well, but that's not a big deal because these are just simple words or simple sentences. So you don't have to use special language at all. So translation is understandable. But the recommendations are again a little bit difficult because Netflix is not the only uh, media that I use. I have seen most of these already, and if I have not seen them, I don't want to see them. I'm not interested. So, because I have been watching regular TV, I have been watching movies in a cinema theater during my flights on the plane and so on, and Netflix doesn't know about them. And another thing is that some of these I have seen in Netflix, but some time ago, so it doesn't remember I have seen them long time ago. So also these recommendations are not very useful for me. A very good example of deep learning use cases is any kind of computer vision problem, visual recognition problem, like image classification, object recognition, object detection, image captioning, action classification, like somebody's cycling or rowing or running, object or image segmentation. So we are separating the object from its background. Examples of that here in the picture, the computer can realize that we have traffic lights, we have a person, but we also have a handbag in the person's hand. We have a car, we have a truck, and so on. So from a picture, it can recognize different kind of objects and classify them. It can be also used for, this example is about social distancing violations. So if two or more people are too close to each other, they are marked as red. If the distance is okay, they are marked as green. And it's a video that is constantly watched by this computer vision. So what if we don't have any data? Well, the computer can, of course, create its own data. Here's an example of one use case. So we want to teach the computer to park a car. I don't show the video, I just show some examples what's going on here. So this is our car, and the job for the car is to learn to park. We have a particular parking slot that it should be, I was about to say hit, but I don't say hit because we will see a lot of hits here. So it's supposed to be parking this slot. After 10,000 attempts, it's still a little bit unsure what to do. After 20,000 attempts, it finds the parking spot and is able to park somehow. 30,000 attempts later, it's still hitting other cars. And the reason here is that this computer has no pre-knowledge about parking rules, like you are not allowed to hit other cars. We do. So when you go to the driver school, you already know all the basic things, like when you are parking, you are not allowed to hit any of the other items in the parking area, including the other cars. And your job is to try to get your car to this red rectangle. So you know a lot of things the computer doesn't. So during this process, the computer is trying to understand what should I do now? What is my goal here? After 50,000 attempts, we are getting closer. We are parking already. 100,000 attempts, yes, we found it. After 310,000 attempts later, the computer is starting to be confident. What did you want me to learn? And learning to do it. Not 100%, but pretty well. The process used here, or the method used here, is called reinforcement learning. So we have the environment, the parking area, that is in a certain state. It gives this state to the agent, the car that is trying to park. The car is making an action, moving to another position. The environment tells the car again where it is and gives a reward. The reward can be positive or negative. So how well did you perform? And based on these rewards, the car learns, the agent learns to park. This sounds simple, but this is very complex because the reward itself, so defining the reward function and defining how and when to give it is quite complex task. So if you think about you're training your dog and you're giving a treat every time the dog does something good, it's understandable. But here, if the car is moving a little bit, is it a good thing or a bad thing because it didn't park yet? If it's hitting somebody, some of the other cars, I know this is bad, so we should give a negative reward. But how often should we give the reward and how big reward? Because this will define how fast it learns to park. So reinforcement learning is very good with games like AlphaGo. There's a link to that if you want to go and read more about it. But is it good with everything else? Because it needs a lot of try and error, and it actually learns very slow compared to humans because we have pre-knowledge so much since we were kids. We have learned so many things that the computer doesn't know. So of course we would not teach the car to park in real life, in real parking lot. So only this kind of thing is possible if we can do it uh, with computer, not in real life. So virtual teaching of the computer. So to Oracle. So what does Oracle has to offer for machine learning? I often hear that Oracle has nothing, or I hear Oracle has too much. And if you are in the middle, you probably already use one or several of the Oracle machine learning tools. But if not, I will tell you some basics about this area. So Oracle has a lot to offer for machine learning. And I'm not going to explain all the possibilities because that's a lot. But I'm going to explain some of the possibilities that you might be interested in. First of all, uh, you can start with the free cloud, uh, the free tier cloud, which means that you can sign up for a cloud that is for you forever without any cost. This cloud includes, for example, the database and machine learning in the database for free, and spatial and graph that might be quite interesting when you move on your machine learning. One option from Oracle is Oracle Analytics Cloud. This is not part of the free offering, but you can use it with the credits you get when you sign up for a new free cloud. There's also a desktop version, Oracle Analytics Desktop, that can be used for testing purposes on your own computer if you want. It has almost all the functionalities the cloud version has. This is an excellent tool for understanding the data and preparing it for machine learning because most of the work in most of the machine learning cases is about preparing the data, understanding the data and preparing it. So if you have a tool that supports that process, you are good. So Oracle Analytics Cloud might be that tool for you. So you find it from the cloud after under analytics. So analytics and then analytics cloud. What I like the most, probably after I just said I love the possibilities of preparing and understanding the data, is that there's so many data source candidates. So I might want to combine different data sources as one data set for my machine learning process. So here I can just combine data from Teradata, Sybase, Oracle applications, Essbase, my autonomous database, my on-premises database, Salesforce, Snowflake even. So I can combine data from so many different sources here as one data for my machine learning process. So here, the concepts we have projects, we have data sets, we have data flows, we have sequences. So a project is kind of a whole thing that you have put together. A data set is one data set, like Excel, table from data, and so on. A data flow is processing this data set to the kind of data you want it to be, combining different data sources, filtering, whatever you do with it. And a sequence can put these data flows together as a sequence. You can prepare the data, you can visualize it, or you can narrate it. Preparing, as I mentioned earlier, is really super good because Oracle Analytics Cloud recommends enrichments and transformations to the data for you. So uh, there's augmented data enrichments. These could be like detecting sensitive data, geographic or demographic enrichments, like for instance, adding a zip code or adding a city. Transformations, dividing the name column into first and last name, and so on. So it can automatically detect that kind of things from your data and suggest you to do it. And you just accept, yes, this is what I want to do. You can also remove social security number or some kind of sensitive data from the data set before you start processing it further. And many, many other things that it lets you to do very, very easily. And of course, you can also add your own transformations or your own enrichments to the process. All this is put in a preparation script, and you can run this script to all the data sets that needs to be prepared in the same way. There's also a very nice feature called explain. So selecting explain to the target column of your data, you will get a very nice explanation about this particular column and it's how it's behaving, how it's is there any anomalies and so on and so on. So it will give you this kind of explanation about that column and how other columns are affecting it. Very good and enlightening. So you can create a data flow. You can just add different kind of data sets, and you can filter, aggregate, and you can save it to the database as a table. So in the end of the process, you can save it in the database if you want so. So there are different ways of using these data flows. Pre-process your data. You can visualize it very easily to understand it better or to show the others what the data is consists of or what it has. Or you can narrate and you can export it to a file or you can print it and you can show it your board or whatever is the group of people you want to explain what is going on with our data. And you can also use the machine learning models that have been created with Oracle Machine Learning for SQL. So you can just register the machine learning model that is existing in your database. So now we talk about Oracle Machine Learning for SQL. So this is one of the features that comes with the database for free. So this is something you can use with whatever database version of Oracle you have. It is free to use since last December 2019. It actually consists of 3 PL SQL packages. DBMS Predictive Analytics, which has the routines for performing predictive analytics. DBMS Data Mining Transforming, that has routines for transforming the data, that it for the way that is easier or better for machine learning models to use. And then finally, DBMS Data Mining, which has the routines for creating and managing the mining models. So these are the packages that include all that you need for Oracle Machine Learning for SQL. It can be used with any tool that can call PL SQL packages. So you just call the package and the procedure or function, whatever it is, and you will get whatever you were wanting with that. So here I'm asking the explain of overall column of my data, beer training data, and it will be stored in the table called beer explain. If you don't like using PL SQL, you can also use the graphical user interface for SQL Developer. So that is a plugin, or I don't know what's the right word for that, but you just add on to your SQL Developer, also free to use. But then you can just drag and drop and build your models without programming one single line. Very, very useful. If you are in the cloud, you also have one more option, which is honestly my favorite. You can use Oracle Machine Learning SQL notebooks. So these are just notebooks, like any of the machine learning notebooks, where you can build your process of teaching the model, seeing how the model works, deciding what version to use, what kind of algorithm to use, what is the for your use case, and then finally implement it. And it also offers a lot of possibilities for graphical, different kind of charts to show how the data looks like. So this makes it easier to understand your data and to see see how it's like divided or whatever. So quite useful as it is. One option more is OCI Data Science that you can find under Data Science and Projects. So each of these data science or OCI Data Science thing is a project. So you create first a project, and under the project you create notebook sessions. A notebook session can be opened, deactivated, or even terminated if you don't want to use it anymore. I'm going to open this one and I will see what I have in my notebook session. So in a notebook, we are using Python 3 at the moment. It's just like any Python environment. You can just use Python naturally in this environment. If any library is missing, you use pip install and you will have it there. So just regular Python. What is not regular is that we have a thing called Oracle Accelerated Data Science SDK, ADS SDK. So this is a Python library that is included in the Oracle Cloud Infrastructure Data Science service. It offers a friendly user interface with objects and methods that describe the steps that are involved in the life cycle of machine learning models. So it's kind of auto machine learning engine. It does a lot of things that you would usually do yourself automatically. And this really makes it faster to deploy machine learning models into production. So the process time gets shorter. Conclusions, what we just talked about. Machine learning is here, it's now, and it's in the future. So this is definitely a skill you should acquire. Oracle is offering so many possibilities for you to start with. So just think, what is the thing that you know the best? Is it SQL and PL SQL? Is it data preparation? Is it the capability of analyze data? Is it do you love Python? You want to do everything with Python, but for some reason you have to use something else now? Or maybe you want to use R, which is already in an Oracle database as well, inside the database, so you can also use R. So what is the thing that you want to come into machine learning space? Start with something you already know very well, and then add these skills on top of it. Oracle offers so many tools for machine learning, so this is definitely not the problem that there is no tool for you. There is, and there might be even several tools that you should be using. They can be used either separately or together. Maybe you want to use Oracle Analytics Cloud to prepare the data, Oracle Machine Learning for SQL to build the models, and maybe Analytics to use the models again. Or I don't know. There's so many options you can choose to build the process that suits you and your company the best. And it's not something you cannot change because uh, you can always add more tools or remove tools because if you're using Oracle technology, it's quite fluent. But knowing Oracle technology gives you a head start because you already know, let's say, the database or PL SQL or something. So you are already much further with your knowledge than somebody who just starts with everything in Oracle space. Everything here is about the quality and the amount of data. And most of us during these years already, we have been preparing data. So we know how to handle data, how to prepare it, and so on. And as I mentioned earlier in my presentation, the biggest part of this whole thing is preparing and understanding the data. So if you've already been doing that when you're building a data warehouse or you're building your operational system or whatever, you already know a lot how to handle the data, how to prepare the data, and how to have good quality data for the machine learning process. You can use SQL, PL SQL, R, Python, Java, whatever language. But the thing is to add the machine learning understanding on top of that. One thing to remember is that Usually, a machine learning project is not one man's job. It's usually a team play. So usually you have at least two people in the process, and one of these people knows something, another one knows something else. And when these people put together all the skills they have, it's going to be fabulous. So you don't have to know everything because somebody else knows that part of the things that should be known. So there's no excuses not to start with machine learning because it's just something you should do and you should do it today. So start learning about machine learning and do it today because this is definitely worth it. It is fun and it's very useful, and this definitely will guarantee your job until you retire. So definitely go and learn more about machine learning, and especially the one that Oracle is offering us, some of them even for free. Thank you so much for listening, and I'm happy to take any questions.